Yeah, so after we introduce the specific features and some advantages of the enhanced insulating paper that we call DPE, so let's explore the application options, how we can utilize this benefit of higher thermal class of DPE paper in layer type transformer insulation systems. And as always in industry, in order really to implement some new ideas, we would like these ideas to be first discussed in details in our engineering societies. And the discussion about the higher thermal class application in transformers actually resulted in development of several international standards. In IEEE, we have IEEE C57-154 standard and also IEEE 1276. An equivalent standard in IEC is 60076-14. So all of these standards actually guide and support application of the higher temperature insulation systems in transformers. Next, please. Thank you. As we just discussed, the DPE paper allows to have a higher class insulation systems. In mineral oil, it can result in the 75 degrees average Weidmann rise temperature systems, and in ester liquid, we can increase temperature up to 85 average Weidmann rise temperatures. And again, on this slide, you see the table where the temperature limits are shown for these different temperature class systems. So 65 degree system, 75 degree system, and 85 degree system. So the standards that I mentioned, they actually clearly define what are temperature limits in order to implement such systems. Next, please. So what could be the benefits of application of this higher temperature system, and specifically higher temperature system based on enhanced DPE paper, either in mineral oil or in ester liquids? So the first actually advantage that we can get is extension of the life of transformers. So transformer life generally is defined, all other conditions being equal, by the aging rate of insulation paper. And on the other hand, aging rate of insulation paper is defined by temperature of the insulation system. So when we create a system that has 10 degrees additional safety margin in terms of thermal capability, then we theoretically can extend the life of transformer more than twice. And obviously, if we have this additional safety factor, we can increase transformer resiliency against increased ambient and or operational temperatures. So in order to understand why 10 degrees results in extension of life, we can look at so-called Arrhenius life equation. So this is equation that you see on the screen, and it's based on the activation energy theory developed by Swedish scientist Svante Arrhenius. And this specific equation is for thermally upgraded kraft paper in mineral oil. So, and for this system, the maximum long-term temperature is 110 degrees. So, and this equation gives us 180,000 hours of life of insulation at 110 degrees. So if we have 10 degrees additional margin, meaning we let's say go to 100 degrees continuous temperature of the system, then the equation gives us 514,000 hours, which is about 2.8 times longer than at nominal 110 degrees. So this is an explanation why 10 degrees results in more than twice extension of the life of insulation system of transformers. Next, please. So, and the other advantages or other benefit that comes from this higher temperature system is higher overload capability of transformers. So, and this higher overload capability can be used in different ways. We can use this simply by have a chance or have capability to run transformer longer for a shorter time. Or we can design smaller transformer with less kVA nominal capacity, and this transformer still will be able to cover necessary overload capability of such transformers. So if we come back to the graph of the loading of the, let's say, solar power transformers, as you see on this slide, let's try to answer the question, what would be the allowable overload capability for the 100 kVA nominal capacity transformer based on this graph? So we can actually convert this graph in initial load and peak load. So let's say we convert this and we say the initial load is 30% of nominal, and then we have an equation how much peak overload we can allow for about 8 hours of the peak conditions. Next, please. So if you look at this loading graphs, so we can look at the curve which represent 30% of initial load. And if you look where we arrive with this curve at 8 hours of peak load, we can find that so-called transformer rating factor for this type of loading diagram would be 0.93, which means that 100 kVA transformer with this loading diagram can be run at 107.5 kVA for 8 hours. So this is allowable loading capability for 100 kVA transformers with normal insulation system with a peak of 8 hours. So if we simply substitute the thermally aggravated kraft paper with this enhanced DPE paper in mineral oil, then we have this 10 degrees additional safety margin in thermal capability, which actually translates in about 20% higher overload capability. So it means that transformer with DPE paper and mineral oil will be able to be used for with the peak of 8 hours with the capacity of 130 kVA versus 107.5 kVA with normal insulation system. Next, please. And the other way to use this additional thermal capability is to design a smaller transformer. Let's say we need the same loading diagram, or we have the same loading diagram, and we need to design transformers that can be used with this loading diagram. So with the higher temperature insulation system based on DPE paper, we can design smaller transformer, let's say 90 kVA instead of 100 kVA. So this would be smaller size, smaller weight, and hopefully smaller cost transformer. And this transformer still will have allowable peak load of 116 kVA for 8 hours. So we see that enhanced thermal capability of insulation system allowed us not only to design smaller transformers, but also to have a comparable or even higher overload capability. Next, please. So the other concept that I would like to introduce that actually based on the higher thermal capability of insulation system is so-called dual temperature nameplate designs or dual nameplate rating transformers. So if we look at historical analogy, we can recall that thermally upgraded kraft paper was developed in 1950s. And then several years later, this paper was actually recognized by the engineering society, and it was standardized as a 65 degrees average widening rise insulation system. So thermal upgraded kraft paper and mineral oil was defined as 65 degrees average widening rise system. And when this new thermally upgraded paper started to be used in the industry, very often it was used as a dual temperature or dual rating transformers as 55/65 dual temperature rating transformer. So on the right hand picture, you see the nameplate of the old transformer. And if you really look closely, you can see that this transformer has 3,750 kVA capacity at 55 degrees Celsius, and it has 4,200 kVA capacity at 65 degrees Celsius system. And both of these levels are continuous levels. They are just they are possible because thermally upgraded paper was used in such type of insulation system. So again, to draw the analogy with what we are discussing today with enhanced DPE paper, we can say that it's possible to design dual rating or dual temperature transformers with 65/75 Celsius in mineral oil and 65/85 or 75/85 average widening rise in ester liquids. Next, please. So the similar idea, actually, the difference between dual rating system and increased overload capability system is that in dual rating system, both level of capacity can be continuous levels. So we can run transformer continuously at both levels of nameplate ratings or both levels of temperatures. And actually, this provides actually a good opportunity, especially in cases where we have a very variable load. And as in cases of renewable energy transformers, where load is not constant. And we can really design transformers that utilize better by have these two different levels of capacity at two different temperatures. And the similar system is discussed as a part of EU Green Deal initiative, and it's called Sustainable Peak Load Transformer. So in EU Green Deal initiative, there are really expectation of significant demand in increase of peak load of transformers in coming 10, 20, 30 years because of the electrification of industry and transport and households. So, for example, on the graph on this slide that came from the discussion on the sustainable peak load transformer, we can see that at the same energy efficiency, the dual nameplate transformer can provide significantly improved material efficiency, meaning significant savings in material at the same energy efficiency. And because we have insulation that can be used at higher temperature, this will not affect reliability or lifetime of transformers. Just to provide us more efficient way to use these available insulation systems. Next, please. So one interesting example was discussed in this sustainable peak load transformer conversation. So here you see on the right-hand side that transformer of dual rating 400 kVA / 440 kVA at 65/95 degrees Celsius can be used instead of 540 kVA transformer or at 65 degrees Celsius. And obviously, this transformer will be smaller, and this transformer will have a less no-load losses. But as a result, this transformer will have a peak capacity of the same 540 kVA, and annual total energy losses will be equal to the 540 kVA single rating transformer. Next, please. So this is actually several concepts that can be used just utilizing the advantages of higher temperature insulation system, and specifically enhanced DPE insulation paper. So to summarize our webinar today, we discussed the challenges that renewable energy transformers facing today. And we talked about variable loads, we talked about inverter harmonics, we have about high ambient temperature, and that all of these increase thermal, electrical, and mechanical stresses on such transformers. Then we said that these transformers become larger and they have high and high voltages, and because they are layer type, they have a lot of paper, and it creates some challenges in production and quality and cost of such transformers. Then we discuss about proposed solution, which is enhanced DPE insulating paper that can be used either with mineral oil or esters. And this paper has several advantages. For example, combining faster dry out, faster impregnation, and enhanced dielectric performance, we can expect improved quality and availability. We can expect reduction of factory acceptance test failure rates and increased transformer reliability and resilience. And then we talked about specifically higher thermal capability of the proposed enhanced system, and the fact that this can be used for optimization of insulation system, high temperature rating design, longer life in operation, higher overload capability, and also interesting concept of dual temperature nameplate designs, or as it's called in Europe, sustainable peak load transformers. So I think this concludes our webinar, and thank you very much for your attention.